The 500 error codes are codes generated by a web server when there's some sort of a problem on the web server end, such as an application crash. The exact cause of these errors can really only be determined by looking at the logs on the server itself. Usually, no details are sent to the client. The 500 internal server error response is a catch-all that simply means that the server has failed to process something and it is the server's problem, not the client's. I typically get these types of errors all the time when writing server code, and it simply means that I have a bug. The demonstration is quite simple. We will visit the server using Firefox and we get back a simple hello message which seems innocent enough, but if we look at the network tab in the inspect area, we see that there is a 500 error code, which is of course marked as an internal server error, and yeah, it's basically me calling an invalid function. The 501 code is generated by the server if a method is not supported by the machine. To demonstrate, we can just switch a simple get operation to the GAT, which generates the response. This of course is sort of funny because in reality it's the client who asked for a bad request, and really it sounds like something that should be for a 400 response. However, the idea here is that perhaps GAT is actually a valid request in our application, but the server is not to configure GAT on this particular resource. You can see 502 bad gateway responses if you configured a reverse proxy on a static server like Nginx, but have nothing listening to handle the actual upstream request. In the example, I have a small node application running, configured to process requests on port 8000, and Nginx is configured to forward the request from port 80 to port 8000, but I accidentally forgot to start the application. When Nginx tries to connect to the application to process the request, Nginx is unable to make a connection and returns the 502. The 503 Service Unavailable response code is usually used to indicate that the server is unable to fill requests at this time, but the client should try again a little bit later. The servers do not produce these directly, but server administrators could send back the code while they're doing maintenance on the server, or it could be part of some kind of an application. The demonstration is just a simple application sending the 503 code and the message, and we can see that we've also included the retry after header to tell the client to try again after 120 seconds. The browsers of course don't do this automatically, it's really an instruction to a client such as maybe a mobile phone application. The 504 Gateway Timeout happens when a gateway is configured, but the downstream server takes longer than the gateway is configured to wait. To demonstrate, I created a small Express application again, responding to the /app route, but the application takes 10 seconds to respond, because maybe it's waiting for a database operation that it has to run. The application is listening on port 8000, and I've configured Nginx to be a reverse proxy to the application, but configured to only allow for a 3-second response time. We can see that when we try to visit the /app route via Nginx, we see a delay and eventually we get the 504 Gateway Timeout. The 505 response indicates that the server is not accepting the request because it has specified a version of the HTTP protocol that is simply not supported by the server. The example here is done using the manual web client where I can type whatever I want, and if I ask for HTTP version 4.2, this gives us the 505 as the response. The 506 code tells the client that while trying to negotiate the type of resource to send back, the selected variant actually caused yet another negotiation to take place, so essentially it's a loop. I couldn't find any reasonable way to configure Apache to demonstrate this, so I'm just going to show an animation for this one. We can see here the client doing a request for the document specifying they would like to have the English version if possible. When the server looks, they find that there are both an English version and a French version of the document. When the server picks the English version of the document, they actually discover that there is yet another choice again between English and French due to some kind of a server-side misconfiguration. The server then has basically no choice but to abandon the request and send back the 506. Well, it's not difficult to figure out what the 507 Insufficient Storage does. The server obviously generates this if there's simply not enough storage to place some kind of an uploaded data. The code is basically derived from WebDAV servers. There isn't really a natural way to generate this unless I attempted to basically use all the available space on the virtual machine, but even then the WebDAV implementation might just return some other error code. The 508 loop detected is a response code for handling recursive links in WebDAV servers. The Apache WebDev module doesn't seem to be able to generate this error, or at least I couldn't figure out how to do it. So again, no demonstration this time. We've just got ourselves just a quick little picture here that you can enjoy. The 511 network authentication is one that we can demonstrate. This is a code that was initially intended to be used by proxies to suggest that a client needs to be authenticated before they are allowed to use the network. Everybody's quite familiar these days with the idea of connecting to the internet from a public location like an airport or a cafe. Normally what you have to do is you have to log in, provide some credentials first to make sure you're a customer or whatever it happens to be. This is exactly what the code was intended to be used for. For the demonstration, I had to write my own small proxy application. But what we're going to do is we're going to configure our web browser to use the proxy, and we'll attempt to visit our normal server, and you can see that we get back a 511 error code with a small link that you can provide for the login. Providing the credentials, or in this case just a simple password, means that the next time we attempt to visit our server, the request is passed through to the actual destination. Something to keep in mind is that the login didn't actually happen on the original server, but rather on the proxy before the packets actually made it. Internet cafes don't actually do this. Most operating systems have captive portal detection built in.